So in the today's lecture, we are going to discuss about the difference amplifier. What is this difference amplifier? It is nothing but when we are going to have more than one inputs to our input and the inverting and the non-inverting terminal, then definitely that output will be available. The output will be available due to both these inputs. Then we can say that what is happening inside, as we have studied in the first lecture, that the first block of your operational amplifier is the differential amplifier. It means whatever the inputs that has been applied here in the form of Vs1 and Vs2 will be subtracted, or you can say the difference of that will be taken and that will be amplified with the gain of the system. Now, earlier we have seen in the case of open loop, the gain was A. But in the case of closed loop, if we are using the inverting amplifier, in the case of closed loop, in the case of inverting amplifier, when we were applying the input only to the inverting, then we said our gain, it is equal to minus Rf by R1. And in the case of non-inverting, we said that our gain is equal to 1 plus Rf by R1. Right? These are the two formulas that I want you to remember. 1 plus Rf by R1, where Rf is my feedback resistance, R1 is my series resistance. So these are the two gains. It means whenever I am applying an input to the inverting terminal, look here, this is my inverting terminal. Whenever I am applying an input Vs1 to the inverting terminal, this input will be amplified by this gain, that is minus Rf by R1. But when I am applying my input to the non-inverting terminal, then the input Vs2, which will have some inputs, will give me some input over here. For example, this is Vx. Then this Vx will be amplified with the gain 1 plus Rf by R1. It means if I'm simultaneously applying these two, then what is going to be my output? Definitely it will be acting as the difference of my two inputs, but what will be my output in exact case? That is what we are going to find out today. So this is the case, this is the diagram of my difference amplifier. This is the case of my difference amplifier, and how I'm going to find the inputs when I'm output when I'm having more than one input. We simply make use of the superposition theorem. So I will make use of my superposition over here. So I will write here, due to two inputs at inverting and non-inverting terminal, inverting and non-inverting terminal, we will apply, I will simply apply here superposition theorem. And what is this superposition theorem? We have also seen it in the last lecture, where we have discussed the averaging and the summing amplifier for both inverting and non-inverting. So over there we have seen this this superposition theorem is nothing but we consider only one input at a time and we take the other input as 0. So let us take that case. In that case, I'm going to take only first as my inverting input. Inverting input. What is my inverting input? That is Vs1. And I will take my non-inverting input. Non-inverting input equal to 0. 0. That is Vs2 is equal to 0. Now, if I draw this diagram, it will be, I will draw this diagram for your reference. It will be like this, where I am going to take only the inverting input. This feedback will be there. This is Rf, this is R1, this input is Vs1. Now, if you look at this non-inverting, we have two resistors over here, R2 and R3, but my input ES2 will be 0. It means I can ground it. So when I will ground it, so this is R2, this is R3, and I will make this Vs2 equal to 0. I will write here Vs2 is equal to 0. Now, it is easy for me to calculate now. How I will calculate? Just a minute. Now, how I will calculate my output V0? I will name this output as V0 dash. Why it is V0 dash? Because I am only considering my inverting input and non-inverting input is considered 0. Now V0 dash, in this case, You see here, okay, I will write it down so that it will be easy for you to. Now here I will write. So V naught dash will be equal to, the input is only applied at the inverting terminal. So definitely the gain in this case will be equal to minus RF by R1 multiplied with the input. What is input? That is VS1. Right? This is my simple case. As I have already derived the scale, so I am writing here that my V naught dash is equal to minus RF by R1 of VS1. Now let's take the second case. In the B part, I will write here B part. That is, my non-inverting input will be considered. VS2 will be there, and inverting input, that is, inverting input will be 0. That is, VS1 will be now considered equal to 0. So my diagram will be my operation amplifier, inverting and non-inverting. These two resistors will remain the same as they are connected with the output. This is RF, this is R1. This will be connected to ground now because VS1 is equal to 0 in this case. And if I look at the second one, these are the two resistors. This is R3, this is R2, and this voltage source here is VS1, which I am taking. Now, we know that in the case if I consider this voltage equal to Vx, we know that if I take this voltage, output voltage again as V naught double dash, because it is for the second case, so I can directly write here that V naught double dash will be equal to this gain. What is the gain in the case of non-inverting? It is, as I said, 1 plus RF by R1 into the voltage at this point. This is the voltage which is Vx. So it means in this case I have to first find the value of the Vx. So how I will find the value of Vx? Anyone? कैसे find out करेंगे value of Vx को? If you look here, this is the voltage Vx at this point. If I take this case only where I have two resistors, let us take, this is my first resistor, this is my second resistor which is connected to ground, and here is a voltage Vs1. Then definitely this voltage Vs1 will be from here to here. It means it will be divided across these two resistors R2 and R3. It means if I have to find the voltage across a single resistor R3, I can simply apply my voltage divider rule. So using voltage divider rule, I can directly write it as that Vx will be equal to the total voltage Vs1 into the voltage across which I have to, resistor across which I have to find the voltage, that is R3, divided by the sum of these resistance R2 plus R3. Now this is the case to find the value of the Vx. It means by simply substituting this value in the V naught double dash equation, I can find the final value of V naught double dash. But for simplification purpose, let us assume, I will use here an assumption. What is that assumption? That is, if R1 is equal to R2 and RF is equal to R. This is my assumption over here. Why I am doing it? Just to make the things simpler. Now by using this, if I see here, yes, any doubts? Yes. Right, beta, this is Vs2. I'm sorry. Yes, you are right. This is Vs2 because I'm considering here the voltage Vs2. I have written it wrong. Vs1 is 0, but we are taking only Vs2, so this voltage is Vs2. Very right, beta. So definitely over here I'm going to change it again. This Vx will be equal to Vs2 into R3 upon R2 plus R3. Now if I look here, by using this assumption that is R1 equal to R2 and RF equal to R3, can I say that my Vx can be written as Vs2, in place of R3 can I write RF, divided by, in place of R2 I will write R1 plus R. This is what I have obtained by simply substituting these values. It means if I have to find V naught double dash, so my V naught double dash, which is equal to 1 plus RF by R1 into Vx, I can write here 1 plus Rf by R1 into Vx, and in place of Vx I will substitute the value which is equal to 1 plus Rf by R1 into what is Vx, it is Vs2 into Rf upon R1 plus Rf. Now look here, this is 1 plus Rf by R1. Can I take the LCM over here? So I will get here V0 double dash will be equal to R1 plus Rf upon R1 into Vs2 into Rf upon R1 plus Rf. So if I see here, these two will be cancelled out and I will be left with Rf by R1 into Vs2. So this is my, if I write here, this is my second output voltage. What was my first output voltage? It was this one, V0 dash is equal to minus Rf by R1. And how to find the total output voltage? Using superposition theorem, we know, as we are applying here superposition, which simply says that the total output voltage will be equal to the sum of the individual output voltage, that is V0 dash plus V0 double dash. So by simply substituting the values, I can write here V0 will be equal to, what was V0 dash? It was minus Rf by R1 of Vs1 equal to minus Rf by R1 of Vs1. Right? What is V0 double dash? As I obtained here in the equation number 2, it is Rf by R1 of Vs2. So if I take Rf by R1 outside, what I have obtained here inside, it is Vs2 minus Vs1. Right? And what is this Vs2 minus Vs1? Or in the other way, if I simply write in the form of minus Rf by R1, in some of the books it has written like this also, so it is one and the same thing. I'm just replacing the gain with a negative value, so you will get Vs1 minus Vs2. It means in the difference amplifier we have got here, the output is the proportional to the difference of the two inputs, where Vs1 and Vs2 are the inputs of non-inverting. If I go back to my diagram, you can see here Vs1 is for the inverting and Vs2 for the non-inverting. So I will get here Vs1 for inverting and Vs2 for the non-inverting. Now these two values or the input voltages is difference. The difference of these two has been taken and it is multiplied with the gain of the inverting. What is this? This is the gain of inverting amplifier. Gain of inverting amplifier. Right? I can also write here as that my V0 is equal to minus Rf by R1 of Vs, where Vs is equal to Vs1 minus Vs2. So look here, this is the output voltage of my difference amplifier. It means whatever the inputs that I am applying at the inverting terminal and the non-inverting terminal, their difference will be calculated at the input and it will be amplified with the right here plus, and it will be amplified with the gain of inverting amplifier. Why gain of inverting? Because I am taking Vs1 minus Vs2. Look here, Vs1 is for the inverting and Vs2 for the non-inverting. It means जब आप inverting की value से subtract कर रहे हो non-inverting को, तो आपका gain भी कौन सा वाला consider होगा? Inverting का. That's why we have obtained here V0 equal to minus Rf by R1 of Vs. Is it clear that how we have got this difference amplifier? If in exam a question comes to you that derive the expression of the difference amplifier and how we can obtain the difference amplifier by using the inputs at both inverting and non-inverting, we can make use of this, right? Now in the exams, or I would say that in the engineering services exams, once a question came that you have to make a difference amplifier but with two operational amplifiers. Now what we have done here in this scenario, we have just made a difference amplifier with single op-amp, with one op-amp. But what if it has been asked to you that you have to make the difference amplifier with two op-amps? How you will do that? So we will discuss that also. So next topic is difference amplifier with 2 op-amps. Now I will draw the diagram for you first, and after that we will calculate the output voltage. So the diagram will be, you can also draw it if you want to. So this is, for example, non-inverting, and this is inverting. Let us take this here. I'm going to take my output voltage. Let this non-inverting input will be Vs2. I'm going to take one more operational amplifier. Over here, I'm going to take this positive and negative. And here I'm going to take, okay, let me take it Vs1. This will be then Vs2. Then I will have a feedback over here. This will be my feedback resistor. And this will be my series resistor, and it will be grounded. But I will write here this. Okay, if I use this one, let this be RF. So I will assume this equal to, okay, we will write it later. And if I connect this with a resistor over here, let this be R1. Then I will say that this R3 and this will be my R2, where R3 is equal to R1 and R2 is equal to RF. Right? These are my two assumptions over here. Look, what I have made different here, that this is although my feedback resistor, but I am assuming that this R3 value is not equal to this feedback resistor. It is equal to the series resistor R1. Whereas the series resistor of this op-amp R2, it is equal to the value of the feedback resistor of the op-amp 1. So I will write here, this gain is A1 and A2. So this will be my operation amplifier 1. This is my second operation amplifier, right? So this, in this scenario, I have to find the output. Now, how I will find the output? Definitely, when we have more than one inputs, we make use of the superposition. So I will just divide my circuit. How I will divide it? Look here. I will take this first operation amplifier, this one. This is my first operation amplifier. So, sorry, second operation amplifier. So I will take this. Okay, I will write here A1. This is first and this is second. So I will take this first operation amplifier and I will assume the output voltage over here. This, as is the output, I will assume this output voltage is, that it be V01. So what is V01? Can you tell me? I can find it directly, as the input is applied to only the non-inverting terminal and inverting terminal is this is grounded. It means the output I can directly write here. It is 1 plus RF by R1 of my input, that is Vs2. This is simple. This is my output of the first operation amplifier, VO1. Now look here, this VO1 is applied. This is an input. This is a voltage which is applied to the inverting terminal over here through this series resistor R1, and we have another voltage Vs1 which is applied to the non-inverting terminal. So again, over here I am having more than one input. I will make use of the superposition. So I will write here, by applying superposition theorem. Superposition theorem to the, okay, I will write here, to the second op-amp. So what will be my output? You can find it by yourself now. I have already explained you in the previous, that is the difference amplifier with one in operation amplifier. In that one I have calculated both the values or the output voltages and I have summed that. So I will write here directly that my output voltage V0 will be equal to minus RF by R1 of V01. It is quite obvious. If I am taking only this V01 and making this Vs1 equal to 0, then the output voltage will be equal to minus RF by R1 of this input voltage, that is V01. So I got this value. Similarly, in the second scenario, when I am assuming my inverting voltage equal to 0 and non-inverting equal to Vs1, so I will apply the gain of the non-inverting, that is 1 plus RF by R1. So I will got here 1 plus RF by R1, and it is multiplied with the input, that is It is VS1 or VS2? VS1. So it is VS1, right? Now we have got here V01, but through the, if you see here, the first stage of our operation amplifier, the first op-amp, we have already calculated the value of V01 as 1 plus RF by R1 of VS2. Oh, sorry, there is a small change here. I am assuming here 1 plus RF by R1, but I can't write here 1 plus RF by R1. The reason is here my feedback register is, if we see here, my feedback register over here is R3. Look here, this is my feedback register R3, and my series register here is R2. So it is 1 plus R3 by R2 of VS2, or in the other way I can say V01 is equal to 1 plus, what is R3? R3 is equal to R1, means it is equal to R1 upon, and what is R2? It is equal to RF. It is 1 plus R1 by RF of VS2. So don't get confused with this, that why I am taking here 1 plus R1 by RF, although it is a non-inverting case, so it should be 1 plus R1. Definitely it is 1 plus RF by R1, but the feedback register over here I am using, that is R3. I have assumed that this value is equal to R1 of my second stage, whereas this R2, this series resistance, is equal to the RF of my second stage. That's why this formula is seems like, or the, when I'm substituting the values, it seems like 1 plus RF by R1 by RF. So I will substitute these values of for the V01 over here. So I will get V0 will be equal to minus RF by R1 as it is, into, in place of V01 I will substitute 1 plus R1 by RF into, what was the input voltage? It was VS2, into VS2 plus 1 plus RF by R1 of VS1. Right? So by solving it, you can solve it. What we will get, if we take the LCM over here, we will get minus RF by R1 into, when we will take the LCM in the numerator, it will be R1 plus RF divided by RF only into VS2 plus, we will take the LCM here also, that is R1 plus RF divided by R1 into VS1. So RF will be cancelled out in this, and I will get here R1 plus, if you see here, the R1 plus RF by R1 is common in both, so I will take it out. It is R1 plus RF divided by R1, and within the bracket I can write here, it is equal to VS1 minus VS2. Now in this case, if I see, I can rewrite it as 1 plus RF by R1 into VS1 minus VS2, right? And I can substitute this VS1 minus VS2 as VS. So I will write here V0 will be equal to 1 plus RF by R1 into VS, where VS is equal to VS1 minus VS2, or simply the difference of the two inputs. So in this way also, by using the two operation amplifier, we can obtain our output voltage equal to the, or you can say is proportional to the difference of the two input voltages, that is VS1 and VS2 with some gain. Is it clear now? Now if you see here that I have obtained a gain equal to 1 plus RF by R1, and the reason for that is the input has been applied, VS1 is at the non-inverting terminal. So if we are taking VS1 minus VS2, definitely VS1 will be considered. VS1 पे जो gain मिलना था आपको, that is 1 plus RF by R1, we have obtained that in the output also. Any doubts related to it?